Hello 101 students. Ryan here to tell you what you need to know to perform the determination of concentration experiment. Before we get into what you're going to be doing in this experiment, let's talk about how it works and why you're doing it. You are going to perform a technique that is used to determine the concentration of colored compounds in a solution. To show you how this works, I've got 2 glasses of some kind of blue drink here that I made by adding a powdered mix to each glass. But I didn't make these drinks the exact same way. One of these glasses has more powdered drink mix in it than the other. If you wanted to know which one has more mix in it, you could tell just by looking at them and seeing which one is darker. In this case, the darker one is the one on the right. It has more blue dye in it, and so when light passes through the 2 glasses, it absorbs more of that light and that makes it look darker. The take-home message is that by seeing how much light a solution absorbs, you can tell whether it's more or less concentrated than another solution. The technique you're going to learn in this lab uses the same concept, but it takes it a step further. Instead of just looking at a solution with your eyes, you'll use a spectrophotometer to measure its absorbance, which is how much light it absorbs. Once you know its absorbance, you can use a chart like this one to translate it into a concentration. If, for example, we had a solution with an absorbance of 0.36, you'd put that here on the y-axis, then come straight over to the best fit line, then go straight down and see what concentration you got. In this case, the line goes to about 0.048, so this solution's concentration is 0.048 grams per liter. Alternatively, you can use the equation for the best fit line and solve for concentration. Taking the data you'll need to make this graph with is one of the first things you'll do in lab. To do this, you'll need 5 solutions of known concentration that you'll make by mixing some stock solution together with some water. The amounts of these that each solution will need will be in a table in your procedure. As you can see, instead of specific exact quantities, this table gives you ranges instead. The second solution, for example, says to add 7.5 to 8.5 milliliters of stock and 1.5 to 2.5 milliliters of water. What this means is you can add anything in that range and your solution will still be good. The nice thing about this is you don't have to worry about dispensing a certain specific volume of stock or water for each solution. The best tool to measure out the volumes you'll be working with is the Buret, so you'll have to set up one Buret with stock solution in it and another with water. In case you're new to the Buret, here's a couple things to remember about using it. To get your Buret ready, you first rinse it with the fluid you're going to dispense from it. You then fill it to somewhere past the 0.00 mil mark and drain a little bit of the solution out, enough to get it below the 0.00 mil mark. There are 2 reasons for doing this. One is it gets all the air out of the spout at the bottom. The other reason is because it is hard, and time-consuming, to get the meniscus down to exactly 0.00, to the point that, for all intents and purposes, it doesn't happen. So, if you are truly reading the meniscus properly, you won't have any 0.00 milliliter readings. To dispense fluid from a Buret, you take an initial reading, open the valve to dispense the volume you need, then take a final reading. You then calculate how much solution you dispensed by subtracting the initial reading from the final. The second thing to know about using a Buret is you have to take your readings to the hundredths place. This means that, since the actual physical markings are in tenths of a mil, you have to interpolate between them to read in hundredths of a mil. To show you how to do this, let's zoom way in on this Buret. The bottom of the meniscus here comes down to a point between the 16.1 and 16.2 mil marks. And if we use our imagination to divide up the space between the markings into 10 segments, you can see it lines up best with the 16.16 mil marking. So we would record this as 16.16 mil. Of course, when you go to do this yourself, you won't have any thin lines to help you out like the ones in this example. And yes, this does make it a little harder to figure out what that last digit is. Just estimate it as best you can, and don't worry too much whether your estimate is a little high or a little low. With some practice, you'll get good at estimating in no time. Once you have the stock and water added to each tube, you're going to want to mix the contents. Now there's a couple ways to do this. You can either stir with a stir rod, or you can use a Pasteur pipette to pump the solution up and down a few times. Just make sure you rinse your rod or pipette between solutions so you don't cross-contaminate them. Once you've got your solutions made, the next thing you'll do is measure their absorbances, as well as the absorbance of a known solution and an unknown. And here's the equipment you'll use to take these measurements. On the left is a spectrophotometer, which is the instrument that actually reads your solutions. And on the right is a small computer you'll use to control the spectrophotometer and view the information it gives you. Now, before you can use a spectrophotometer to measure anything, you have to calibrate it. Start by plugging the computer's power wire in and turning it on. Once it's booted up, plug in the USB cable that attaches it to the spectrophotometer. After a few seconds, the computer will figure out it's attached to something, and you'll get a big red box on the screen. Use the stylus to poke the box, then select Calibrate. You'll get some message about a dark reading, then a countdown timer for the lamp to warm up. While you're waiting for the countdown timer to finish, you can prepare a blank cuvette and put it into the spec. To do this, you fill a cuvette about 2/3 full of water, wipe its sides down with a Kim wipe to make sure you get all the fingerprints and dirt and junk off it, then put it in the sample holder, making sure you have it in the right orientation. Getting it in the right way is easy, just make sure the arrows on the cuvette and spec point at each other. As soon as the lamp has finished warming up, finish the calibration by pressing Finish Calibration, then click OK. To measure a solution's absorbance, put some of it into a cuvette, enough to fill the cuvette about 2/3 full or so, then wipe it down like you did the water cuvette, put it in the sample holder, and press the play button on the computer screen. Give it a second to finish the reading, then press the stop button. What you get is a graph with absorbance on the y-axis and light wavelength on the x. You can check the absorbance at any given point by clicking on a part of the graph and/or using the keys at the bottom to move back and forth along it. I'll leave it up to you to figure out what part of the graph, that is, what wavelength, you want to select to take your absorbance measurements at. That's what you need to do to collect your data. As always, before you leave, make sure you dispose of all waste solutions in the proper container and clean up your glassware. For the Buret, rinse it several times with DI water and leave it with its valve open.